Okay, so just now we have seen some of the horror stories and we have seen the four rules of the Menlo report. And what do they mean to us? And I'm talking about the data scientists in industry. And if you want to do PhD or if you want to do research, and then probably your bar will be even higher. Okay, so well, I'm talking about what we need to do in industry. So the very first thing is understand that the tension between the usefulness and the anonymity of the data. And what I mean is I can't have a really useful data, and yet I have a really high standard about the anonymity, especially if this data is generated by people. Okay, it's not impossible. And this reminds me of what is said by the President Obama. Well, he said it's important to recognize that you can't have 100% security and also then have 100% of privacy. So, well, those two things, he argues that those two things cannot happen in the same place. And if you want to search, if you search this sentence on Google, and then you will find another sentence said by Benjamin Franklin. And it is really funny when you put those two sentences and those two heads side by side. Well, go ahead and do the search and you will find that. Okay, so what is said by Obama, is that correct or not? I don't want to debate. Well, and what the point I want to make is, well, if you want to have a really useful data and then you want to be really safe, and well, usually if this data is not generated by person, it might be possible. For example, like weather data, the data can be useful and yet it is safe. Well, but if you are dealing with the data generated by person, and you can't have a really useful data, and yet the data has a high level of anonymity. And the reason is you can remove all the identifiable information like the SSN or the emails. However, there is still a risk that we can re-identify the person or re-identify part of the person. So we always have this kind of risk. So you can't assume that okay, the data is anonymized, so I'm 100% safe. So it's not really like that. So if you have a data and then you believe you have already finished your job, you don't have to use the data anymore, and you can ask your boss, is this okay if I destroy this data from my own machine? I don't want to keep that data on my machine. And if there is a server hosting this data in your company, and go ahead and just delete that data from your machine. And then when this data is leaked, and at least you are not responsible for that. Okay, and the second part is, well, the biased data will generate biased models, and we have seen this example. So if you bring up the Google image and you want to you do a search of the cat, and you see a bunch of the different cat, and what's the problem? One of the problem I have seen is it doesn't cover all the species of the cats. And well, one of the example I show you is this one. This is a hairless cat, and this is a special species of cat. So if we have a biased data set, and then it's very likely that we are going to generate a biased machine learning model. And well, can we fix this? Definitely. And should we, the scientists, be responsible to fix that? Definitely. Okay, we definitely want to balance the data set and make sure that all the different categories or all the different classes are well presented. Do we want to have the same number of the training sets for each cat species in this case? Well, not really like that. But if we have a data set that we only have one sample of the hairless cat, and then I will say this data set itself is wrong. So if this dataset is already a garbage, and one of the rule of thumb in the world of data science is the garbage in, garbage out, right? So this, if the dataset is biased, and then it's very likely that our model will always be also be biased. So the next thing, well, unbiased data may still generate biased model. Well, even though our dataset is not biased and our results from our model may still be biased. And one of the reasons is, well, it really depends on how we want to evaluate a machine learning model. And you may say, to evaluate a machine learning model, we have seen a lot of different ways, right? Well, if you're doing regressions, and we can do the mean of the average error, or the mean of the squared error, or the mean of the error percentage. Well, if you're doing the classification, we have the confusion matrix, we have the percentage, the accuracy percentage. So those are the things that we have been using all the time. Well, but if we are dealing with subgroups, now it is a new story. So let me give you an example. So if we have a model, and then we have the model to predict a risk of a type of the virus among Asian, black, and white people. So does that sound a little bit risky to you? Well, we are predicting, well, the likelihood of the infections of a disease or a virus among different group of people. And then how do we evaluate this machine learning model? So we can evaluate the machine learning model in different ways. So the number one, well, we want the machine learning model to be fair, and it should equally accurate in predicting the likelihood of the infection for the members in different racial groups. So this is one way that we want, one of the factor we want to maximize to make it work the best. And another way is that, well, it should assume that all the members of different groups have the same chance of being wrongly predicted. Okay, so we don't want to treat a specific group of people really badly. And the number three, well, this machine learning model should assume that the failure to predict the infection rate happens at the same rate across all the groups. So you may feel like those three standards are kind of the same thing. But the question is, can we maximize three of them at the same time? And there is a research saying that is not doable. We can maximize two of them, but by maximizing two of them, it will guaranteed harm the third. Okay, what is that? Well, that is called I call that pig-2 triangle. And one of the easiest pig-2 triangle is, well, for college students, if you want to have good grades, your social life, and enough sleep, that's not doable. You can pick two of them. Okay, so for those three standards, that's the same thing. They will form a pig-2 triangle. You can pick two, but it will harm the third. And then when the third is harmed, what does that mean? People can always use the third standard and say your model is biased, right? So that's a problem. So even though we have three subgroup of people, and then we have the unbiased data set, well, depending on how the result is evaluated, our model can still be considered to be biased. Well, in this example, we are just trying to predict the likelihood of the infection. Well, like coronavirus, and if you tell me, Dr. Sang, you are 80% likely to get infected by coronavirus, I'm concerned. Well, but I'm not insulted, right? Well, if we change the problem to something else, if you're trying to predict the tax frauds, or if you're trying to predict crimes, and then we are still using three group of people, Asian, black, and white, now this is a much serious talk. Okay, so it's not that our algorithm is wrong, but depending on how the machine learning algorithm is evaluated, people may still argue that our machine learning algorithm is biased. So guess what? My recommendation for you guys is, well, if you are dealing with this kind of machine learning model, when you are presenting that, you should first acknowledge that your model might be biased. Okay, so don't let other people to point this out to you, because, well, how about you just acknowledge that by yourself, and you can say, depending on how this machine learning model is evaluated, and I will say my machine learning model can be biased. And for example, if you look into a specific subgroup of the samples, and you may find that the error rate is high. And if you say that, and then people will let it go. Okay, so the very last thing, well, there will be legislations implicitly address the danger of the commercial use of the personal data, but it will come very slowly. Well, if you consider the FERPA was a very old legislation, and yet, well, there's no big update since 1970. Okay, so well, the legislation may happen, but it will be much slower. And then, well, when you enter industry, and then when you're about to do some data science project, and make sure that you understand your company should be in charge of should be offer you the right training before you start to touch the sensitive data. Or if your company doesn't really do that for you, and another trick you can do is, well, have a serious talk with your boss, and then after that write a email as the meeting minutes, send it to your boss and say, hey boss, well, this is what we have been discussed, and could you see if everything I have remembered is correct, and if so, could you send me a reply as a confirmation. Okay, so now you have a written confirmation in your email inbox showing that your boss has confirmed that the project is doable. So the risk is not just on you, because you and your boss will share this responsibility. So this is a trick you may want to do in industry. Okay, so that's all I have prepared for today, and I know the knowledge is not that well organized, but this is the best I have prepared. Okay, so if you want to bring me more cases I should put into this lecture, and go ahead and contact me. And otherwise, I guess this will be the last video lecture. So thank you guys very much, and you have been very patient with me. This is a weird semester, and I hope everything is going well and you are well and healthy. And well, I will see you guys next semester. Okay, bye.